Okay, so we're in Introduction to Statistical Learning, Chapter 5, Question 6. So here's the question. So we are returning to the data set on which we did the previous question, Question 5. Okay, so if you haven't seen that, you may want to watch that video. But we're going back to the default data set, and we're trying to predict somebody's probability of defaulting on a loan given their income and the balance on their loan. And so we're going to do this in two different ways. So the first way that we'll do it is with just the standard GLM function, just a stock function in R, and we'll look at that. In fact, that's what we used previously in question 5. And then we will use a bootstrapping method that will take a little bit of looking into the code to see what's happening. So we're going to do that, and then we're going to compare the results between the two methods and comment on it. So the first thing you need to do is load the ISLR2 package and load it into the library. And then we need to get the data up and going. Okay, so that's what's going on here. So data default, and so again, this data set is in the ISLR2 package. I'm just relabeling it D here. Okay. Okay, so and then you can see the first few rows of D if you want to here. Okay, so part A, so we're going to find the standard errors using this GLM function, okay? So this is the function right here, okay? So I'm just calling it mglm. So I run GLM, generalized linear model, and I put my formula in there, just like we did in the previous video. It's a logistic regression, which means it's binomial with a logit link. And I'm using the D as my data. Okay? And so now if I bring in the summary command, so I run the summary over this model, this is what I get. And this won't really mean anything to us right now because we're meant to compare this to another method. But this is what we get here. Okay, so here's our coefficients as well as intercept, the estimates, and their standard errors. We're going to be asked to compare standard errors, but we can also compare estimates. Okay. Now, in part B and C kind of go together, I guess, but in part B, we're asked to construct a function that we're calling boot.fn that takes the default data set as well as an index on the observations and outputs the coefficients. Okay. So in other words, what we do is we're going to make a function that runs exactly this, okay? But instead of returning, we want it to return something. We don't want it to return the entire summary that we get here. We just want these guys right here, okay? We just want the estimates. So in other words, if we were to say coefficient of mglm, give it a second to run. You see down here, this is the output, right? So we get this matches this, okay? It might not look the same because this has e to the +1, which means we put the decimal over here. Income is here, so on and so forth, okay? So we're going to create this function, and it's just what we did, but it's just going to return the coefficient estimate. So it's not going to give us the standard errors back or the z values or the p values or anything like that, right? So again, we just get the coefficients back, okay? So there's that, okay? And now in part C, we're going to do C and D together because in D we're just asked to comment on the comparison between the two methods. But we're going to use a function called boot, which is not to be confused with boot.fn, which is what we just created. But we're going to use the boot function from the boot package, okay, to estimate the standard errors from our logistic regression. So in other words, so we have our boot package. So we need to install it, which I've done here, and then load it, okay. And then I tell the boot function, I say use the default data set. In fact, I could call that D. That's what we're calling that. Use the default data set. And then I want you to calculate a particular statistic 1,000 times. Now, what is that statistic or set of statistics in this case? Okay. Well, it's the output of boot.fn. Well, what is the output of boot.fn? Well, it's this right here. It's the coefficients. It's this right here. In fact, maybe let's see that here. So if I say boot.fn d 1 through n row of d, okay, we get this. Okay, so this is just one run of boot.fn, which again is just giving me these guys right here. Okay, so so boot is going to run boot.fn many times, but it is just going to be calculating the coefficient values, not the standard errors. Or boot will run it many times and then calculate the standard errors from many runs of the boot.fn function. I hope that makes sense. I should also point out that what the boot function is doing, it is bootstrapping, it is sampling the data D with replacement, right? So it won't always get the exact same data set, right? It's going to sample D 1,000 times, right? So that's why there's variation in run to run to run, right? Because we're always getting slightly different data sets because we're sampling the data to get bootstrap samples. Okay. So anyway, I'm not going to run this live because to run the bootstrap it takes a few seconds or whatever. But when we finish running that, we get this. We get this output right here. Okay. And then I've also reloaded the summary from our initial GLM function right here so we can compare them. Okay. So this corresponds to the intercept. Okay. And we notice that these are very close, as they should be, right? We see here, this is the income estimate, and we see that that's very close, and so on and so forth. And we can compare the standard errors as well. This one looks to be not great, or not super close. Maybe not super close. Oh, I'm sorry, because I'm looking at the bias. Okay, so looking at the standard errors are very close. For all of them. Okay, so anyway, that's it. So I guess that the assessment of all of this is that the errors as well as the estimates are similar between the two methods, which of course is what we expect.